There I am. All right, here's your homework. So Aaron owns a rare baseball card. He bought the card for $7.50. That's your initial amount. In 1987. And its value increases 6% each year. Positive rate, 0.06. Write and use an exponential growth function to find the baseball card's value in 2015. So I need to know from 1987 to 2015 how many years went by. So 1987 to 2000 is 13 plus 15. That's 28 years. So how do I set this up? And you can go back a page to look at the formula, follow along. This is what it looks like. And then use your calculator, and you get the price of the card. So now the card is worth $38.34 by typing that in your calculator. Number 2, Jennifer started working at her job, earning $6.25 per hour. That's the initial amount. Every 6 months, she gets 3.25% raise. Move the decimal. Make sure you change the percent to a decimal. If Jennifer has worked at the job for 14 years, what is her hourly rate? So to understand this, because it's every 6 months, how many times are we doing this? So in 14 years, how many 6 months are in 14 years? And the answer is 28. So if it's every 6 months, how many 6 months are in 14 years? And the number is 28. So it's $6.25, 1 plus 0.0325 to the exponent 28. Type that in your calculator, and now she earns $15.30 per hour. Number 3. In 2005, the Somerville Journal had 110,000 subscribers. The number of subscriptions subsequently decreased. Well, that's important to know, by 8%. Write and use an exponential decay function to find the number of subscriptions in 2020. All right, so how many do we have to begin with? 110,000. At what rate is it decreasing? 0.08. And then after how many years? So from 2005 to 2022, that's 17. So now we write 110,000, 1 minus 0.08 to the exponent 17. And then use your calculator. And that's 26,655 subscriptions. So it went from 110,000 down to this number using a decay model. Number 4. In number 4, in November, 26 students at a high school had contracted the flu. Another infectious disease question. Each month, the number of students who have contracted the flu increases by 36%. So our initial amount is 26. The rate is increasing at a rate of 36%. Write and use an exponential growth function to find the total number of students who have contracted the flu by May. So each month, that's the rate. So how many months have gone by from November to May? So November, December, that's 2. And then how many more in May? 5 more. I get 7. Or matters how you started, I guess. If it's the beginning of May, then it would be 6. If it's the end of May, it would be 7, right? So 6 months have gone by if it's to the beginning of May. And then it would be 26, 1 plus 0.36 to the exponent 6. And then how many students have been infected? And so the answer is by May, 165 have gotten the flu because of that. Number 5. Ian bought a new truck for $35,000 in 2015. Each year, the value of the truck depreciates. Yeah, it goes down in value, 9% as a decimal. Write and use a growth function to find the value of his truck at the end of his 60-month lease. So it depreciates each year by 9%. So how many years are in 60 months? That's why I'm using 5. So 5 years is 60 months, right? It's 5 times 12. So it's 35,000. 1 minus 0.09 to the exponent 5. What's the truck now worth? Put in your calculator. And now the truck's worth $21,841.13. Let's read again. A certain compound has a half-life of 4 days. Write and use an exponential decay function, as it's decaying, to find the amount of compound remaining from a 75-ounce sample after 3 weeks. Okay, so 75 ounces is what we're starting with. My rate is half, 0.5. Get my picture out of there. So it's half, but it's half every 4 days, right? And then 3 weeks, I need that in terms of days. So 3 weeks is 21 days. So that's what we're going to use. And then what's the setup from here for half-life? So it's 75, 1 subtract 0.5. Here's the challenging part. If it's every 4 days, then you divide by 4, and then how many days? And it's 21. So the more you practice these, the more you'll set up the formula more efficiently. Put that in your calculator, and how much is left? And the answer is 1.97 ounces as it's decaying after 21 days. All right, number 7. A 7-foot tree was planted in 1984, or 4-foot tree. That's the initial height. The tree grows continuously, 22% each year, as a decimal. Find the height of the tree after 8 years. So for this, because it's continuous growth, the formula we use is this. And then when we use this formula, the initial amount is 4. E is a number in your calculator. And the exponent is 0.22 times 8. And that's what you put in. And then the answer is 23.25 feet. Number 8. An ice sculpture measures 52 inches. And melts continuously by 3% per minute. Find the height of a sculpture after 15 minutes. So those are the numbers we're going to use. So it's 52 e to the exponent 0.03, but it's negative because it's melting, times 15. So how high is the sculpture after 15 minutes? So sad, it's already now down to 33.16 inches. Done. Number 9. Sam shaved his head down to ½ an inch for a swim meet. If his hair grows continuously at a rate of 1/4 inch per month. So first of all, he started with ½ an inch. The rate is 1/4 an inch per month. That's how much it grows. Find the length of his hair after a year. So the rate is per month. So this has to be 12 in order to match, not 1 year. And then the formula would be 1/2 E, and this would be positive. So it's 1/4 times 12. So we don't even have a percent as a decimal. We just have a number. Now, if you want to make it easier, 1/4 of 12 is 3. So it's 1/2 e to the exponent 3. And so his hair after a year would be 10 inches long. Get a haircut already. All right, last 2 questions for the homework. Number 10. A population of fish in a pond from 2001 to 2014 is modeled by this function. It says use it and find the number of fish in the pond in 2014. So how many years have gone by? 13 years. So just plug 13 in and use your calculator. Super simple. So even though the formula looks scary, if you just have to plug in the right number, just do that. You can use Desmos to help you. And we're going to do it to the whole number, not a part of a fish. So approximately 486 fish will be in the pond after 13 years. All right, last one for our homework. Number 11. Bears in Alaska are limited to a certain area, live due to the resources available for food and shelter. After T years, this function describes the bear population. Using this function, find the number of bears after 17 years. So again, all you have to do is plug in 17. And that's it. So if you use your calculator, whole number, there'll be approximately 91 bears there after 17 years. So we started with 103, and after 17 years now there's only 91. There it is. All right, your homework's done. Mr. G Math, over and out. Till next time.